Hello, I am Rebecca Karen. I am the event planner for the Microsoft Reactor New York, and thank you for joining us for this Reactor live stream event. Before we begin, I'd like to just quickly review two items, our code of conduct and event guidelines. So let's just pace through this quickly. So just to sum it up, Microsoft is really here to empower every person and every organization. And that includes our events here. So we just seek professional, respectful environment. So make sure that you're keeping on content mostly, you know, jokes and engagement is perfectly welcome and accepted, and we love it. Just make sure that we keep it, you know, respectful throughout. The event guidelines, this session will be recorded. So if you do have your video on, you will appear on the recording. So if you don't want to do so, just make sure you keep your video off. And it will be available later on our YouTube channel, which I will drop the link into the chat for that as well. If you have any questions while the presenters, Paul and Peter, are presenting, do feel free to drop them into the chat just to not disrupt. But there may be time later on for questions where you can unmute yourself and get a little bit more engaged. If you need closed captioning, it is available. Just select those three dots in your settings and turn on live caption. So that brings us to today. So in this session, we are joined by Paul DeCarlo, a principal cloud developer advocate from Microsoft, and Peter Gallagher, a software consultant and Azure MVP, who will introduce us to the Azure Percept Dev Kit. This workshop is part of a series of events hosted throughout the month of July that explores operational technology and IoT. So I will drop the links to their website as well. This session will run for approximately 30 minutes, and there should be time for questions. So at this time, I will let Paul and Peter take over.
All right, thank you for the introduction, Rebecca. So yes, we are here today to talk with you about the Azure Percept. And what we're going to specifically focus on a little bit more in detail in today's session is the audio features of the Percept Dev Kit. So we will be looking at introducing this. So if you are not familiar, the Azure Percept Dev Kit, you can find out all about this on the Azure product page, which will allow you to learn things like pricing, how to order, where this might be available, but also just get to understand what this device really is, which at the end of the day, it is a device that's able to make sense of the real world using onboard sensors that come with the Azure Percept Dev Kit box solution. So what this means is that we have a camera module that sort of comes along with the device that's referred to as the Azure Eye. This allows you to run computer vision workloads for doing things like object detection or classification, in addition to an Azure Ear module, which makes sense of sounds. So it's actually got an array of microphones on the device that can hear things that you say and be able to fire off events based on the intent provided in your speech. Now, once you've acquired one of these devices, the first thing that you would want to go ahead and do is head on over to the Azure Percept documentation page. And the reason why I say this is that this is really the one-stop shop for being able to get to learn everything that there is to do with the Percept Dev Kit, as well as getting started, in addition to things that might be up and coming as we go ahead and build more and more features for this device over the coming months. So when you first get this device, you might be wondering, how do you actually interact with it? It's really similar to most sort of IoT devices that you would buy off the shelf. There is an out-of-box experience where you connect to a Wi-Fi endpoint that's served by the device. From there, you enter in credentials that will allow you to sync this device up to something we call an Azure IoT Hub. Now, how we're going to actually interact with this device is utilizing a service within Microsoft Azure called Azure Percept Studio. This is going to be a way that's going to allow us to really, without writing any code, be able to deploy a number of different workloads down to the device. And these can include things like custom object detection models or even custom speech applications that you can deploy down. It will be made use of on that associated Azure Eye and Azure Ear module. Now, once you've gone through this out-of-box experience, the first thing that you will see is that it's going to associate itself with an IoT Hub. And if you peek into that IoT Hub service and really look at the workloads that get deployed down to the device, you'll see a number of different modules. The two of which that we'll be interacting with today are the Azure Eye module and the Azure Ear Speech Client module. And these are effectively going to run the workloads that we're going to deploy in just a moment from the Azure Percept Studio. And how this all works underneath the hood, if you're curious, is this is leveraging something called the Azure IoT Edge Runtime, which is something you can certainly go and check out if you'd like to learn more details on how this actually works underneath the hood. So the first thing you'll see when you head to the Azure Percept Studio is whether you know what you're doing or not, it's going to give you a bunch of examples and sample projects, demos and tutorials, and things that you can try out to very easily familiarize yourself with the device. In fact, what we'll go ahead and do is really show how quick and easy it is to get started once you have your device already registered with an IoT Hub to be able to try out sample vision workloads. So what I'm going to go ahead and do here, you'll see in the demos and tutorials section, it gives me options to try some of these. What also happens when you deploy your device is there is a device section, and you'll see here that any of my devices that have been registered with the hub, I can go ahead and click into, and we can quickly jump in and start to deploy to those devices.
Paul, I'm not sure if it's just me, but all I see is your Percept page, the product page. So I don't know if it's just me or not.
Oh, interesting. Yeah, we can go ahead and reshare if there's a screen share issue right now.
I don't know if it's just me. It might just be me.
Excellent. Let's go ahead. Is anyone else seeing issues with the screen share? Okay.
No, it's
Yeah,
just Mark
just
says
see
it's
the
just me.
Azure.
Okay. Excellent.
Percept.
Okay. So we're
Oh, no,
moving
not
right
just you,
along.
Johnson, yeah.
Yeah, it looks
Yeah.
like
Yeah.
may need to refresh there. Okay, so the first thing we'll do is go ahead and click on the Vision tab here, and you'll notice that I can jump right into deploying sample models. What I love about this is that really with just a few clicks, you can get started with, if I want to identify common objects, perhaps utilizing the YOLO object detection algorithm. You can also do things like
It's
detect.
still not working, I think.
Let's see. Go ahead and
Still
reshare one more time.
Yep. Oh, that's it. It stopped at that point. I don't think it actually stopped the last time. That's better. That's it.
Excellent. And that should fix that. And so you should see here a number of different sample vision models that we can deploy out. So these include things like general object detection for deploying to or being able to see multiple different objects, people, in addition to vehicles. So in just a few clicks, if you wanted, you could very easily go ahead and start to develop proof of concepts or prototype applications that could service a variety of different use cases. But we're going to go ahead and jump in to show how you can actually detect custom objects. So for example, if we utilize something called the Custom Vision AI service, you'll see there's an option here to deploy a custom vision model. We can choose any of our particular projects that exist in our subscription and deploy those latest iterations down to our device. So I'll just go ahead and show how easy that is with just a single click. But while that's going on, we'll sort of talk about what Custom Vision AI is behind the scenes. So Pete's going to give us a quick little demonstration or example here of what this actually is for those that this might be new to.
Yeah, so thanks, Paul. Custom Vision AI is a no-code solution that allows us to be able to leverage the power of AI without needing to actually be a data scientist. So what Paul will probably flick through is that we're able to upload a set of sample images, and then we can draw rectangles around the particular items of interest in those sample images and tag them with what we already know that they are. So you could draw a box around an image that's got, say, a Raspberry Pi in it, or an Arduino, or a Jetson Nano in the case of what Paul's showing you there. And then we are training the system at that point to what these particular objects are. And then once we've uploaded enough, and you're probably going to need, say, 15 of each object to get this to work, we can then train this AI model so that it can then recognize on the fly and return to us what each of the items in a particular image or video stream are. So, Paul, did you want to show how that was working?
Sure. So just as Pete said, after we've got enough sample images and they're tagged appropriately, we can go ahead and train that and produce a model. So in this case, I'm showing my latest iteration. And once you've trained this, you can actually export it out, not just for running on your Percept Dev Kit. You could also run this on your mobile phone or even in a Docker container if you so choose to perhaps throw this out onto a device that you might want to run your workload on. So now that we have this custom model deployed, it's very easy to go ahead and see it in action. We can actually head back to Percept Studio and under the Vision tab, select View Stream. And this will launch an ability for us to speak to our device, provided we're on the same network. And you can see that model in action actually pointed at some devices on my desk at the moment. And what's really fascinating about this is all working, even though we're in, you can kind of tell it's a bit of a low light condition, we're still getting high accuracy just based on the number of samples that we had. So hopefully that gives you a good idea on what you can accomplish with the vision side of the dev kit. But as we mentioned, we're really going to focus more today on the audio features that are available in the device. And so what's really interesting here is, again, if we head back to that overview, one of the sample demos and tutorial sections that they have here also happens to apply to speech. So we can click down here to try out voice assistant templates. And this is really cool. As long as we associate this with one of our IoT hubs that has a Percept Dev Kit registered to it, we can deploy a workload from a number of different templates. These involve hospitality, healthcare, inventory, and automotive, and be able to interact with our device, again, without really writing any line of code. So I'm going to go ahead and click down here, agree to the terms, and select Create. And this is then going to bring me to an ARM template, an Azure Resource Manager deployment that's going to deploy out a number of different resources to facilitate the next demo that we'll see. We can give this a quick prefix here, deploy in the associated region that we want. And then you'll notice down here, it mentions the Lewis prediction pricing tier. So how this all works underneath the hood is it's actually built on top of a service called the Language Understanding Intelligence Service, or Lewis, which Pete will go ahead and explain a little bit more about how this works and makes the audio features light up on the device.
Yeah, so thanks again, Paul. So yeah, the Lewis service is sort of a brother or a sister to the custom Vision AI. So using natural language models, it's going to grab the intent from our spoken word. So if you imagine that we've got a set of words that we say and they form a sentence, the Lewis service can use natural language understanding models to then take the overall intent out of that. And then what we can do is we can build on top of the Lewis service to add things like text to speech and speech to text to be able to give that full circle interaction between us and the technology we're trying to control.
Well said, Pete. So yeah, it's a really interesting service that will allow us to really turn our vocalizations into intents that can drive interactions from our device. So now that we've deployed this sample application, one of the first things you'll notice here is that we have the option to utilize a variety of custom keywords. So if you've ever used a voice assistant device, this is probably familiar to you. I'm going to go ahead and choose the following, but it is important to note here, you can actually customize this, and Pete is going to show that in just a moment as we deeper dive into this demo. Now from here, I'm going to go ahead and grab my device, and we'll actually show this just responding to a few commands so you can kind of see it in action. This is my Percept Dev Kit, and you'll notice over here on the right where the blue LEDs are, this is effectively the ear module that's going to be able to listen and respond based on the sample application that's been deployed to the device. So I'm going to go ahead and try this out with a few sample commands using that custom keyword. Computer. Computer. Turn on the lights.
Okay, turning all the lights on.
Computer. Turn on the TV.
Okay, turning the TV on.
Computer. Set the temperature to 80 degrees.
Set temperature to 80.
So as you've seen, as I'm speaking to the device, this is causing interactions within the sample application. Now, this may or may not be impressive to you depending on what you were expecting today. So Pete and I have actually gone ahead and decided to take this demo and really overhaul it. In fact, if you look behind me, you'll see that we've actually replicated the hospitality room here in my home office. So what we're going to go ahead and do is now kick on over to Pete, who's going to explain a few more advanced topics in development for the Azure Ear module and show you how you can get started controlling real devices using your Azure Percept Dev Kit.
Absolutely. Yes, I mean, we wouldn't be very good IoT builders if we didn't try and do this ourselves. So yeah, Paul and I gave ourselves the challenge of controlling the objects that you can see in the room behind Paul. So you saw the sample demo there had a room with a telly and a light and a thermostat, and it had a few other things as well. So that's all controlled using a set of commands. So we're over here in the Azure Percept Studio and the overview page. If we go to the speech section here, we can see here we've got the commands, the keywords that we can wake up our device with. And I've trained a few of these. I trained it with my co-host's name, Clifford, there, and also with, well, I tried Paul's last name, but that didn't work all that well. So I settled on this word here. Now, I'm not going to say it because that'll actually wake my Percept up. So there is a word there that we will use in a minute to wake it up. But you can train pretty much any keyword you like, so long as it's got more than 2 syllables. And it's a pretty fast process, actually. You just type in the word, it trains it to listen to that word, deploys it down onto your device, and you're off and running. So once you've got the device woken up, then we need to be able to control some actions. And we do that with a set of custom commands. So just like in the sample there, and it can recognize things like turn lights on and turn telly on, we can do that same thing with our own custom set of commands, and this uses Azure Speech Studio. So this is a software as a service package that's built on top of Lewis and then a few other bits of Azure services to be able to deal with text to speech and speech to text, and we can also handle things like chatbots this way too. So what I've got on the screen is the turn light on command, and we're in an example sentences page here. So the way we train each of these commands is we need to tell Speech Studio the various different ways that we want to, in this case, turn the light on. So you can see the first line there is turn the light on, and we've pluralized that here, or we could just say lights on or switch the light on. So there are various different ways, and I could carry on with that with perhaps using the word lamp instead of light. But that's great. And it's going to allow us to recognize that turn the light on command, but that's not going to complete this circle. That's not going to actually turn the light on. We need to then complete an action after that. And so over here on the left, we have the concept of web endpoints. So once the Percept has understood that we want to turn the light on, it can reach out to any web endpoint we like. And so we can create a set of those here. And once we've defined them back in our command, we have the concept of a completion rule, which I've called done here. And you can then complete that particular command by reaching out to an endpoint. And then we can return an audio response in the form of natural language back to the user to say that we've successfully understood that command and enacted it. Now, if we go back to that web endpoint, you'll see that we're using if this, then that as a service to be able to do that. Paul, did you want to just explain how we're using that?
Yeah, sure. Let me kick on over to my if this, then that applications, or what they call applets. So if you've not used this service before, this actually allows you to develop a number of different, if you want to think about it like change reactions, it's kind of hence the name if this, then that can leverage a number of different devices and services. And when Pete and I were sort of thinking, how could we build this hospitality room, I already had these Wemo smart plugs on hand at my home. And I thought to myself, well, let's go check out if this, then that has support for that. And surprise, they did. But this supports a number of different devices. So just to look specifically at the one we're using here, it is a Wemo smart plug that you can buy pretty much off the shelf. You can order this off of the internet if you need to order one. And it has a number of different actions that can be applied to it. For example, turning off, turning on, then off, toggling, and that sort of thing. And what we can do is pair this with the built-in functionality of a webhook for being able to create a smart application that we can then trigger with our voice from Azure Percept Studio. Now, how the webhook portion works is anytime you create an applet, there will be this section that can come along with it. If you enable it, you select documentation, and this will show you exactly how to call that. So you'll see here, it gives me a URL along with an associated key. And as long as we provide the name of the event within that URL call, that will actually trigger that event to fire off the if this then that chain that we've created within our application. So with that said, I'll go ahead and kick it back over to Pete, and we're almost ready to show you a demo of the hospitality room in action.
Yeah, I mean, I won't spend long sharing my screen now, but you can see here on the web endpoint screen, this is that same URL that Paul was showing you there to be able to turn on the lamp, where we're passing in the key at the end, and then that particular function, turn on lamp percept. So essentially what we do is we can turn the lamp on. It will recognize one of these different sentences. I'm not going to use the word lamp because I've not trained it. And then once it's recognized it, it will call out to that endpoint. So yeah, let's stop sharing the screen and we can give it a go. Hey, so I've trained my Percept with that different wake up keyword. So controller, turn the light on.
The light was turned on.
That's great. And we can turn it off. Controller, turn the light off.
The light was turned off.
And then obviously you saw in the sample demo, there was a TV. So controller, turn the TV on.
The television was turned on.
And what I love is that Paul's using a good old school CRT TV there and a 1990s console as well. He's a man after my own heart for his love of retro gaming. I've got a loft full of old retro computers and yeah, good man.
Well, you know, what's awesome here too, Pete, is I don't know if our viewers are aware, but you're all the way in the UK and I'm in Houston, Texas. And this is pretty awesome that you can do this kind of stuff. I mean, who knew, you know, power of the cloud, the internet. I'm sure not everyone here is fully surprised about that, but still cool enough to say. But we left something out here. In our demo, we also showed controlling the thermostat. So we'll go ahead and kick on over how we might be able to accomplish that. So I'm actually going to show a previous project that was written up on the Hackster.io blog, where we leveraged Azure services to be able to control my Nest-based thermostat. So Nest is a smart thermostat brand that you can pick up quite a few different places. However, it's not exactly straightforward how you can interact with it via an API. So if you are interested in how we've sort of reverse engineered that, you can check out this article, which we will link to again at the end of the presentation. But this will show you how you can get the Nest API tokens from there and also do a little bit of sleuthing to understand things like structure ID and get a client code that we can effectively use to create something that will allow us to call what looks just like what we saw before, effectively a web endpoint using our voice. Now we're going to do this a little differently though. See, if this and that was really nice in that we didn't have to host anything. We literally just went in there, clicked a few buttons, write no code, you get a working chain of commands. But what we're going to do now is take this up a notch and head into Azure Functions, which is a serverless offering that we have here. And we're going to go ahead and create ourselves a custom function utilizing an HTTP trigger. So if you were to look at that article, it actually uses an event hub. We're going to modify that slightly to be an HTTP-based trigger. And from here, we can actually come in here and start to write in the language that we've chosen our function to use. And there's a variety you can choose from, including things like C#, Python, and also JavaScript, as you see here. And so what we can do here, if you sort of look at how this code is working, it's effectively making a web request and securely passing along credentials while it's doing that to effectively allow us to set the device to home. So if you're not familiar with how the Nest devices work, there's not really a concept of on-off. It knows whether you're home or away, so that's kind of a similar way to control that. And what we're effectively doing here is, again, storing those secure values here within our Azure function, using that to build up a request that we call out to our device. And what's really fun here is when we demo this time, you can actually monitor this on the Azure side and really see exactly what's going on behind the scenes when this gets triggered. So I'm going to go ahead and kick it back over and bring up my Nest thermostat, which should at this point in time be set to away. It actually does not think that I'm home currently. And Pete is going to show us how we can again trigger that utilizing the Percept Development Kit.
Yeah, we'll give it a go. So just in the same way that we're able to issue the wake up command and then a custom function command that we had there, then we have one for the thermostat. So controller, turn the thermostat on.
The thermostat was turned on.
And you can see in the background there that it was triggered.
You can see here the success of the actual function getting triggered. And I guess that's just going to take a moment for the Nest API. Usually doesn't take this long, but should just take a second here for it to get the notification.
It's always going to be slower when you demo it.
Of course. But for the most part here, it does look, actually, you know, it's funny. I think the app is not updating because there we go. There we go. So we are set to home and all controlled with the power of our voice using the Azure Percept Dev Kit. So we are getting to close to the end of our presentation. I did want to share a few things with everyone on the call before we go into Q&A. Number one, if you are wanting to learn more about the Azure Percept, you will want to head over to the short link at aka.ms/perceptdocs. This will show you everything that you need to get started with the Azure Percept, be able to learn everything that you can do with it, and also the place where you would stay tuned as additional features and functionalities light up through the coming months. If you were interested in learning more about the Nest controller function that we saw at the end of the presentation, this will show you everything from obtaining those API keys to building the function itself. You can head to aka.ms/Azure Nest Assist. And finally, as you are aware, this session today is part of #JulyOT, which is a content repository where we're publishing new content every day throughout the month of July, or should I say JulyOT, and you can head to aka.ms/JulyOT for that. And this will give you a number of different links to various different things. This includes all of the JulyOT Reactor live sessions, which there's quite a few interesting ones coming up from a number of my colleagues. So you'll learn about Azure Defender, transforming data, in addition to a cool example showing the Altair classic device running on an Azure Sphere. And if you do check out the JulyOT page, this will be updated every Thursday. So you'll want to come here, kind of hit refresh on this, or even just check out what's on there right now, as there's a number of different links here to things about the Azure Percept. We've got some cool projects that show how to build a Lego obstacle avoidance car using the Percept. Some awesome articles written by Pete, as well as our other colleague, Clifford Agius. So you can check out a lot of cool, fun stuff here if you're interested. And so with that said, I see we've got a couple minutes here. Maybe try to take on one of the questions from the audience. This is a good one. Torin asks, is it possible for the Azure Percept to run code locally when an intent is recognized?
Yeah, that is a good question. And certainly my understanding is that that is the plan. But at the moment, I think it's expecting the internet to be there. So actually, when you go to the Percept docs here, if I just share my screen for a second and zoom this in a bit, you actually, I'll share this link in the chat there, but the audio processing is done as follows here. But offline in the section, if the device is offline, it will detect the keyword and capture the connection status telemetry, and an increased false accept rate for keyword spotting may be observed as keyword verification in the cloud cannot be performed. So you can absolutely deploy Lewis workloads down to IoT edge devices, but I believe at the moment, because this is quite new, we still need the connection to be live. That's my understanding.
Yeah, excellent question, Torin. Thank you for that. And we may have time for one more before we sign off.
There was a good one there about languages. Is it English only? Jishnath asked. And certainly the speech service can support up to 92 languages currently, I think. So absolutely not English only. You aren't limited. And again, the beauty of it running in the cloud is that number's only going to keep growing as well. So.
Excellent. So yeah, I guess the last thing we'll leave you with, definitely check out hashtag JulyOT 2021 this year. Be sure to visit the short link at aka.ms/JulyOT. Pete, how can people stay in touch with you as you are the resident expert? I'm sure you're going to get a lot of questions after today's session. How can people find you?
Yeah, Twitter's always the easiest. So at Pete_Cozy, you can see that there at the bottom of the screen. That tends to be my favorite place to interact with people. I am on LinkedIn as well. But as Paul mentioned, there's a couple of blogs and there's some more coming to the Tech Community IoT blog page there. So do go and check that out. The link was shared there by Paul, but we'll put them in the chat as well. So yeah, do get in touch. I love talking to people about this sort of stuff.
And similarly, I'm at PJ DeCarlo on Twitter. I'd like to thank everyone for joining us from around the world today. You know, as much as COVID has been a nuisance for a lot of the normalcy that we've had, I do love that when we are able to give presentations these days, it's with friends and family from around the world. So wherever you are today, be safe out there, and really, we truly appreciate you joining the session. And we look forward to hearing about your awesome projects and ideas for JulyOT, so keep us posted.
Thank you, Paul. Thank you, Peter. This was fantastic. That was a great session. And yep, I've been blowing up the chat with those links, so definitely click on those guys, check it out, see what else is coming up. As Paul mentioned, there's a few more sessions, part of the Reactor series, and then we always have content coming out, so check out our event calendar. Thank you all so much. Have a good one.
Thank you.
All right. Thank you. Cheers.
Cheers.
Bye now.